explain you the second method, which is the intersection method. Now in intersection method, what is done is we should know two ground points. Like this is a ground point A. Similarly, we should know another ground point which is B at a known distance. Okay. Let us say my ground point B is 20 meter away from here. So how much is that distance on plane table? Is 20 centimeter. So what I do is that I will draw the direction of that point with the help of the alidate. So let us keep a flag at the other point. Let's keep a flag at the other point. Now the record method. Intersection method. As I told you, intersection method is faster. Here we are not taking any distance measurement. So this is simply based on the coordinate geometry, that if I intersect one object from one station and intersect the same object from another station which is known to me, the intersection will give me the point. So once I get a point by intersection method, I can measure this distance on the plane table and convert into ground distance. So it's a simple coordinate geometry I am using. So here, let us say this distance A and the distance B where that person is standing, surveyor is standing, is 20 meter. This is known to me. So this 20 meter will be 20 centimeter at 1:1000 scale. Okay. So what I draw here is that from A point, let us say now this is my A point which has been transferred from the ground, same way as in radiation method. Okay. So from A I will like to fix up the direction. So here I fix up the direction and this is my direction. Now I can see that flag. This is in the line of sight. So I draw a line which is 20 centimeter on the plane tabletop. So this is my A point and this is my B point, and this distance is 20 meter on the ground, 20 centimeter on plane table at 1:1000 scale. So this distance is known to me, orientation is known to me, direction is known to me. So if now I want to plot the corner of the building, same again, we have to take a flag. We will like to simply from A, we will like to simply bisect the corner. So this is in the same line of sight. Now the flag is in the same line of sight. I have kept the flag at the corner of the building which we want to plot, and see here this particular point, that now the alidate is also aligned in the same direction. So what I do simply is that I will draw a ray. I don't know how long the ray to be drawn, so I'll draw a long ray. This is towards the building. Okay. So for my memory I can write that this is towards building. Okay. I want to plot a tree or a corner of this particular fence. Then I will draw the ray towards that particular. So this is the direction in which the corner is aligned, and I'll draw a ray now. So this is the ray which I will. So what we find is that another tree here, that large tree. So another object I will like to draw the ray. So this is towards that another object. So this is the line towards the tree. So likewise, you are drawing the rays in all the directions for all the objects which are surrounding point A. It could be this side also. So in all the directions. And then once we have finished this point A, what we do is we will shift our plane table from A to B. So we will shift our plane table here. So can you see that point 20 meter away? So you have to now shift your plane table there at 20 meter. And again you have to do leveling. Again you have to do centering and orientation. Orientation now you are doing with respect to this line. You know this line. With respect to this line, you have to do the orientation part. Okay. This is clear?
Yes, sir.
Now from B, let us say we are standing at B point. Now from B point, you are again aligning these objects. Okay. So once you align these objects, let us say you are aligning the corner of the building from B again. So this is your alignment. This is your direction. Okay, from B. So from B, when you make the alignment, if this is the alignment, you draw the ray. So this ray is towards building and this was also towards building from A. Now intersection point is giving me the corner of the building. This is that corner of the building. So similarly, you have to plot other corners of the building and then you have to draw the shape of the building. Now you know the direction of the tree from A. Now from B, you again bisect the direction of the tree. And once you have bisected properly, you draw the ray and intersection is giving you the direction of the tree and you plot the tree. So this is the exact location of the tree. It is the exact location of the corner point. Similarly, the fence corner. So you have bisected now fence corner from here and this intersection is giving you that particular corner. So you start getting the details, getting the points, location by intersection method. Like we do coordinate geometry problems. If we know the distance, if we know the two directions from two sides, by intersection we can get. So that's why this method is known as the intersection method. Now, I like to know how far is this particular building from A. I have this distance. So I know my plotting scale, I know this distance, I can find out how far is this. How far from B, I can find out this. But what about elevations of these points? Elevations we can find out without keeping the staff. We are using here tangent clinometer, tangent clinopole. So if I use tangent clinometer, clinopole from here and take tangent theta angle, I know the elevation of this, I know the elevation of this, I can find out elevations of this. So in intersection method, we are not taking a staff reading. Because what we are assuming is that our points are very far off. They are on a higher ground. So it will take a lot of time to go there with the staff. So you need some indirect method. And clinometer is an indirect method where you are directly getting tangent theta value. So once you know distance, once you know tangent theta, you can find out elevation of this point if I know the elevation. So this instrument, tangent clinometer, which I have explained you earlier, we are using this instrument along with the intersection method. We are using staff and level along in the radiation method because our objects are close by. In intersection method, our objects are far off. So we cannot send a person with the staff. It will take a lot of time. So quickly we take the observation from this tangent theta value. We know distance, we know elevation, we can find out elevation of these points. So we have to write elevation right on the plane table so that contouring can be done. Okay. So in this experiment, what you have to do is that you have to first of all use radiation method for the nearest points in the area. Your scalar plotting is 1 to 1000, and the farthest points you can use for farthest point intersection. But remember, for both the methods, you have to take elevations. I want RLs to be plotted on the plane table so that you can do contouring at the later stage, or maybe in the field itself. So I'll explain you, actually these are done in the field, but I'll explain you some other time how contouring is done in the field. So today's exercise clear?
Yes, sir.
So this experiment will continue for 3-4 turns. You have to prepare the map of this area at 1:1000 scale using radiation method. And now there are 2 more methods which I will explain you next time. Okay? Yes. So if the experiment is clear, you can start your experiment. Okay?
Thank you.